Good morning, good afternoon, good evening, wherever you are in the world. Thank you very much for joining us today on this great panel, which is part of the Cambridge Festival, and is titled, Can We Cool a Warming World? We have 4 excellent speakers. First, we have Dr. Shaun Fitzgerald. He's the director of the Center for Climate Repair. Professor Hugh Hunt, and he's the professor of engineering, dynamics, and vibration, the Faculty of Engineering, and deputy director of the Center for Climate Repair. Ilona Mettiäinen, she's a researcher at the Arctic Center at the University of Lapland, and Alice Well, a PhD student at the University of Exeter. So thank you very much, everybody, for joining us this morning. Here's like a beautiful cloudy morning in Cambridge, nice and sunny. So the way we're going to do this panel, we're going to just go basically straight to sort of asking each panelist some questions, and we see how everything goes. Now, I encourage the audience to also ask any questions in the Q&A, or if they want as well, you can raise your hand and we can take questions like that as well. So we'll make it a bit more interactive. So first of all, then we'll go in the order of Shaun, Hugh, Alice, and Ilona. So Shaun, just to start, now we had the latest summary of the IPCC report out this week, and it talks about the need for deep, rapid, and frankly, in most cases, immediate emissions reductions. Is this possible?
Well, it is the killer question, Antoinette, and the message of what's being needed for deep and rapid emissions reduction, and that word rapid is really, really important. And have we been listening? Well, we may have been listening as a society. Do our actions reflect our intelligence of listening and then doing something appropriate about it? The really unfortunate thing is that if we look back in history over the last 30 years, we have not been cutting the emissions that we should have been doing for the last 30 years. And the grave concern that we have is it possible? I think theoretically it probably is, but I'm not sure is it possible is indeed the right question. It's, do we have the will? And there's a huge, huge issue here as a global society to go and make these cuts, because it's like we've got a big tanker that we need to turn around. And are we going to be able to turn it around fast enough in order to avoid the sort of the forecasts that we're looking at right now of sort of climate change, where it's way north of 1.5 degrees centigrade in terms of temperatures? So theoretically, yes. The bigger question is, do we have the willpower as a global society to actually get on the journey and do it?
Excellent. Thank you so much, Shaun. Now that's a great start actually for the conversation. Now, Hugh, if we have a tech fix to cool the planet, then we will all just relax and carry on burning fossil fuels. What's your view?
Well, it depends a little bit what you mean by a tech fix, because of course we're full of technology already, and arguably it's technology which has got us into the mess we're in, because we've got so many devices, machines that we need power for, and that's why we're burning fossil fuels. I think we're going to need tech fixes, whatever they are, to stem global temperature rise. Some of these tech fixes sound a bit scary, and so maybe we'll be scared off them. But then if we find ones that don't sound scary, that is what worries me. If there are non-scary looking tech fixes, then maybe we'll take our foot off the accelerator and just relax, and quietly things will get worse.
Thank you, Hugh. Now, in relation to sort of how things are going to get worse, and now this question goes for you, Alice. Sort of like depending on the conversation, sort of that we're having, and we often hear in relation to, like, sort of a stratospheric aerosol injection, And what could you explain a little bit of what type of other climate intervention strategies we could use to reduce sort of global temperatures, and if you want to expand as well on that, the stratospheric aerosol injection as well.
Yeah, so I guess in terms of like the sort of technological fixes, there's been suggestions around something called solar radiation modification. So trying to artificially cool the planet by increasing its reflectivity from solar radiation. So one of these sort of technologies, like you mentioned, is stratospheric aerosol injection. And this essentially, as the name kind of suggests, we're injecting aerosol, typically SO2, into the stratosphere. And when SO2 oxidizes, it becomes this really reflective sulfate aerosol. So aerosol are just particles suspended in the atmosphere, and if it's very reflective, then when incoming solar radiation is reflected on these, it forms this sort of blanket around the planet and therefore cools the planet by reducing the amount of sunlight that reaches the Earth.
Thank you, Alice. So, Ilona, now there also in relation to SAI or solar, there are actually more. Are there any other targeted methods to cool the planet? So, could you tell us more about targeted interventions?
Sure. So solar geoengineering is of course like a rather well known among climate intervention techniques. But that would have like global impacts and like it's considered as a very kind of all-encompassing and big technique. But there is a group of methods that would be more locally applied. Especially they are targeted at maintaining the cryospheric elements as they are now, so keeping them frozen, like the permafrost, Arctic sea ice, or ice sheets and glaciers. So, for instance, ice sheets conservation is an idea that would, by placing a curtain in the sea bottom close to certain calving glaciers, it would slow down the access of warm seawater to the glaciers and thus slow down their melting. And this might actually, especially if it would be applied in Antarctica, it could slow down or reduce the sea level rise quite a lot.
Thank you. And then now sort of like moving on to understanding the whole picture. And I think sort of like this question might be a little bit for everybody, but we're going to start with Shaun first. Now, Shaun, what are the big challenges in reducing emissions?
Right. I mean, the big challenge in reducing emissions is actually willpower, right? And it's because the issues that we really have as a society, look, there are lots of things we can do, and they're relatively cheap. So if we go and look at the shifting away from fossil fuels, the cost of renewables for electricity generation is often much lower than other forms, fossil fuel derived power plants these days. So that's all really great. And we should get on with this as quickly as possible. The bigger challenges are certain areas of our activity set which require fair amounts of investment, and either the payback period is very long or the benefits really are going to be felt by others. So let's look at one that's very dear to my heart, which is how we heat our homes. So homes are responsible for, or buildings rather, are responsible for something like 40% of energy/carbon emissions in the developed world. Homes are representing about 20% of those. The homes that really matter are not the new ones coming down the track. The homes that really matter, the elephant in the room, are the ones that we already have. And what is the carbon source? Well, many of us in the UK at least have fairly old homes. Anything pre-1980s is probably not going to be considered new, and the insulation levels and they're not built to a great standard. Why they're not built to a great standard is, unlike Ilona, we don't live in particularly harsh climates, so the levels of insulation that we've really had to put in to make sure that we're warm, we've got away without there being awesome levels as you do in Scandinavia, for example, and further north. Now, we heat our homes with oil and gas largely, which means we have gas boilers, oil boilers, and they cost what, £5,000, £6,000, even sometimes a bit less than that for a replacement. That when we heat our homes, we're burning gas, and out of the flue stack, that's carbon dioxide going straight out to the atmosphere. And in the UK, we've got 27 million homes. We're going to need to basically switch out of gas boilers. And the real problem, if we want to decarbonize the existing estate, remember, it's like 20% of carbon emissions in the UK associated with, frankly, our homes. We've got to get away from oil and gas boilers. And what's the alternative? There are two alternatives. The one that's available today are heat pumps. Heat pumps are about 3 times the price. So we're going to ask people to invest in a heat pump that's £15,000 to £20,000 for a heat pump. That's if it's an air source heat pump. Ground source heat pumps even more expensive. And weirdly, if that's all you do, your utility bills are likely to be even higher, because you won't be able to operate with what we call high coefficients of performance. They're going to be fairly inefficient because we have small radiators that are used to supplying lots of high temperature fluid to the house. That's the way our houses are built. So one of the biggest problems we've got is that I, as a homeowner, should be switching out my technology from a gas boiler with small radiators to a heat pump with large radiators. And in a moment we say large radiators, well, we should be doing insulation. The investment I need in a typical home is certainly north of £50,000, more like £100,000. And we've got these big issues regarding the scale of investment that's required, and then who's going to be paying for this? It's going to be me. Who's going to be benefiting really from the reduction? It's the future generations. So because it's all about taking greenhouse gas emissions down, and therefore going on a different trajectory. So the big challenges we've got are the large investments that are going to be needed, and the pace of change, of climate change, being really quite sort of a slow effect, and therefore the really real beneficiaries are not the old fogies like myself, the wrong age of 50. They're going to be the youth of today who are going to be the beneficiaries of my investments today. So these are the sorts of challenges we've got, Antoinette, regarding just focusing on emissions reduction. We've got to do it, don't get me wrong. It's a prerequisite for anything that we do for sustainable humanity, but it isn't going to be enough.
Thank you, Shaun. Now, if it's not going to be enough, and now Hugh, this is a question sort of for you. So whatever we do, are we sure that this is the best for everyone? I mean, or do we care more about what happens in London and Miami than we care about what happens in Calcutta and Lagos? So what's your opinion?
Well, I mean, that's a tricky question, because we see pictures of polar bears that are struggling in the Arctic, and we see pictures of the impact of climate change. But these things we see on the television don't really have an impact that hurts our lifestyles. We just carry on doing what we're doing. I wonder whether we need a big climate crisis, which will hurt us. Maybe we need a period of a couple of years where some really important places in the world get flooded. Now, what do we mean by really important? Why is Calcutta and Lagos, and so why are they not important? Because they've already been flooded. Isn't it crazy? We're waiting for somewhere that's really important to get flooded before we do something. So do we care more about Miami and London and so on before unless these places start getting really hit, we're not going to do anything. Look what's happened already with hurricanes and flooding in Houston and in New Orleans and in New York, and yet it hasn't changed our attitudes very much, because the Western world, even relatively poor people in the Western world, can afford to protect themselves, or there are ways to rebuild society. But It's not the way it's working in places like, well, I mean, when there's a big flood in Bangladesh, or what we've seen in Pakistan recently, it takes years to try and get life back to normal. So whatever tech fixes we have, just hope we're not just thinking of how to look after ourselves. We've got to look after everybody.
Thank you, Hugh. Now, in relation to looking after everybody, and then Ilona, this is sort of directed for you. So, why is it important that we do research on climate repair with communities in the Arctic as well as in the Global South?
Thanks for this question. So sometimes people talk about refreezing the Arctic in order to save the global climate, or sometimes, especially in the research on let's say, solar geoengineering, there's been some claims that the views of communities in Global South or the Arctic have not been heard enough or should be heard more. So this is basically, so when we are considering the designs and the techniques and stuff, so it's important to think like about the impacts, how they are distributed, whether particles are placed influences, let's say changes on precipitation or droughts or something like that. So it's basically like a very practical impact issue, but it's also a justice issue. So if we talk about refreezing the Arctic, so it's also important to pay attention that, actually, could you show some of my slides? I think if you started with the first slide, please.
Sure, let me see, make sure we have them all done.
So the picture that some people have about the Arctic is that it's basically empty. There's just, well, some these iconic polar bears that are used as symbols of climate change, and that there's the sea ice, well, as long as there is sea ice and glaciers and like that. But essentially, what is forgotten is that the Arctic is also a home. So if you think about refreezing, thank you. Yeah, okay, could you show that one, please? So this is a Google image search, and these basically are the pictures that you can see when you search for images of the Arctic. But then if you scroll down, there's slides, I think it's number 3 and 4.
There. Keep going to the next one.
Yeah, could you switch to the presenting mode? No.
Yeah, certainly.
Yeah, thanks. So yeah, so basically these kind of icy pictures, so these are of course true as well. These are pictures I personally taken in Ilulissat in West Greenland of their famous icebergs. So yeah, but I said, so the Arctic is also a home, and Arctic peoples may, well, they should also have especially indigenous peoples, they should have a say in what comes to the design. So already when hearing them in the research, gives information that can be used later on when at some point if global decisions on let's say solar geoengineering are done. Could you show number 5, please? It's the, okay. Yeah, thanks, the one with the maps. Yeah. So many people think, as I said, that there's hardly anyone living in the Arctic. And of course, the region is very sparsely populated. There's only about 4 or 4.5 million people in the Arctic. But as you see, there are many settlements throughout the region. And on the left-hand side, you can see groups of indigenous peoples. So it's also a home, and these people should also be heard. But what comes to the Global South, they shouldn't be forgotten either. So for instance, there's this Decimals project that has aimed to produce knowledge about the possible impacts of solar geoengineering, how it would influence these countries, so that they would also have the knowledge base for equally participating in any decision making.
Thank you. Now I'll just stop sharing my screen. So let me see here. Okay. So thank you so much for that, Ilona. And now, Alice, then in relation to like sort of the climate effect of a solar geoengineered world, would that be the same as the climate effects of a world under global warming?
I guess the simple answer to that, at least kind of in the research that I've been doing, is no. But a lot of the sort of modelling studies that look at stratospheric aerosol injection are focused on temperature goals. So if we were to look at the global mean temperature of a geoengineered world versus that of the world that you were aiming to be, then yes, it would be the same. You know, you're targeting, or you're trying to reach a temperature target, and in these modelling scenarios, we reach those targets. So in a very top level global mean temperature sense, yes, it would look the same. But when you start to look at sort of the regional differences and changes in precipitation and regional temperatures, there are, you know, some subtle differences. And that's because when you inject a layer of aerosols into the stratosphere, they don't just sit there on their own doing nothing. They're interacting and they're changing, or they interact with sort of large scale dynamics, which has impacts on the weather and climate. Having said that, though, these changes in, you know, regional patterns aren't always a negative. So often when we've looked at like SAI deployment strategies, they can have some really negative impacts depending on how we do them. But in some of the work that I've been doing recently, when we've looked at the regional changes in things like heavy precipitation events, so when we're trying to look at the extreme precipitation indices, there are some regions that actually improve, so i.e. they're not having these drastic rain events compared to the warming scenario that we're trying to meet. So we tend to take a high emission scenario and cool the planet to a sort of more medium tier emission scenario. And so we then sort of make comparisons between our goal and, i.e. the sort of global warming world versus the geoengineered world at the same temperatures. So it wouldn't look the same, but it's very much a case of an unequal distribution of changes as well. But in terms of global temperatures, they would potentially be the same.
Thank you, Alice. Now I'm just encouraging the audience to actually ask questions. We have a few coming through, so I'm just going to go to the Q&A section and see you know, the ones we have. Now, I'm just trying to see what would be okay. So from Garth Wilkinson, and perhaps this is actually a question that for all of you. So, and then we'll keep with the order. So we'll go, Shaun, with you first. So, can tech fixes solve environmental degradation and biodiversity loss? And climate change is not the only challenge. What do you think?
It's a very, very important question. Because, and in fact, the IPCC report out this week, actually, I thought did a rather good job in that it really overlays that it's not just climate, it's climate and nature in the broadest sense, and biodiversity loss. And, you know, a lot of these problems that we have of a warming world are, frankly, the incredibly horrible impacts on our natural world that these are going to have. So right now, for example, the acidification of the oceans, the bleaching of the coral reefs, that's just, you know, as you know, the bleaching of the coral reefs, this is just the warming effect. But when you have the acidification overlaid with this, and then just the biodiversity loss that we are seeing, not just from climate change, but from, frankly, other elements of our activity. So climate change, in large part, that we're worried about are the anthropogenic root causes, in other words, what we have done, but what we have also done elsewhere to the natural world is really, really terrible. So we've got to go and think about it in the wider sense that we need to be looking after our partners on this world, you know, the natural world. And if, for example, there is a desire to say, look, we need to sort of, well, a realization perhaps that we're not going to be moving quickly enough, and therefore we need to go and put a techno fix if it's going to be something like geoengineering or stratospheric aerosol injection, that is like Band-Aid, and it's a pretty poor Band-Aid too. It is not curing the underlying root cause problems, which are the fact that human activity has led to an increase in greenhouse gas levels, and other activities on top of that being very, very negative to the natural world. We've got to tackle those root causes. So this whole topic of, can we cool a warming world with some, potentially some of these techno fixes? It's one part of the jigsaw that we are exploring today. The really big part, the really big actions on the jigsaw are these fundamental issues about how we think about the world, how we think about others in terms of just emissions reduction, if there are technical fixes regarding solar radiation management, and then lastly, in terms of, could we even suck carbon dioxide out of the atmosphere? This is to really sort of, given that we've spewed so much carbon dioxide into the atmosphere, it hangs around for thousands and thousands of years. Are we going to therefore look at approaches that we might be able to devise to increase the absorption of carbon dioxide out of the atmosphere to sequester it somehow? There are technologies that we can develop for this, and they are all important that we develop our understanding of these and get deploying those which have got the sort of the right attributes to this. But the pace of change that we're looking at on emissions reduction and greenhouse gas removal are fairly slow. So Garth, you're completely right. If we're looking at acidification of the oceans and things like this, if you're going to introduce something like stratospheric aerosol injection, my gosh, we've got to go and address these other issues about the natural world at the same time. We must not ignore those.
Thank you, Shaun. And I see Alice as well, sort of nodding. So Hugh, I'll go to you afterwards. I'll just go first to Alice. She's just nodding her head. Go on, Alice.
Yeah, no, I just completely agree with Shaun. Whilst it's really important that we research things like stratospheric aerosol injection, because what we don't want is for a rogue actor, for instance, to just implement it without having all the facts. At the same time, we cannot at all ignore the fact that the only way that we can really solve climate change and sort of fix what we've done is to reduce our emissions and try and get back to where we were. And climate change, often we think about more in terms of heat waves and the temperatures rising, and what we don't often talk about as much, at least in this sort of community, is exactly that, biodiversity loss. And that's such a huge factor, because you have so many then feedback loops that would then actually cascade into like a tumbling effect of impact. So it's hugely important not to focus on just this quick fix, because actually there are many other consequences that come with that. And exactly about ocean acidification is a prime example of that. That would not be solved with things like geoengineering, or at least solar geoengineering. So it's definitely an important point to raise, for sure.
Thank you, Alice. Now, Hugh, I see you nodding your head as well. So what are your thoughts?
Well, my thoughts are related to this slide here, which is, I don't know whether you can see it, I hope you can, but the if we think of plan A, if geoengineering is plan B, if we think of plan A, then how well is plan A working? So I don't think plan A is working, because carbon dioxide levels over the last 20 years have risen 40 or 50%. And you can't just explain that from population increase, because population increase hasn't risen as fast. So the energy consumption per population is growing. Now, you'd like to think that because we've got solar panels and wind turbines and things, that maybe our carbon dioxide use per unit energy is getting better, but no, that's pretty much stayed the same. So whatever we might think about the negative impacts of geoengineering and what this might, we've got to be really careful of thinking of the negative impacts of doing nothing, because this is the way we are going at the moment. Our behaviors are not are not really changing fast enough. So we might not like all the impacts on biodiversity, and we might not like all the unintended consequences of geoengineering. But I suspect we might not like the consequences of doing nothing. Just for a bit of completeness, just for those that perhaps might not know what we're talking about when we're talking about geoengineering, this slide might just help, because if we imagine that, oh, well, we just need to plant lots of trees, that's the sort of in the middle here. Well, you know, that isn't going to be enough, and it's not going to happen fast enough. The sorts of things we're looking at is pumping carbon dioxide deep into the ground, maybe getting carbon dioxide into the oceans. But again, these things are not going to happen fast enough. We've got to do all these things, absolutely. But the kind of things that Alice has been talking about in terms of solar radiation modification, stratospheric aerosols in the top here, the sulfate aerosols that Alice was talking about will help to reflect sunlight. Clouds, maybe we can make clouds whiter to help reflect sunlight. And people are thinking of putting giant reflectors in orbit to reflect sunlight. These are the fairly wacky tech fixes that we've been alluding to. We need to do the research. Alice, just you can't say it often enough that people might not like the idea of deploying the ideas that you're working on, but you're working on giving us a greater understanding of what the impacts will be, so as hopefully to minimize the unintended consequences of what is, I think, inevitably geoengineering. And that's another question that's been posed, is that David Mackay, I've got his book here, great book if you've not come across it. David Mackay, Sustainable Energy Without the Hot Air. He was pretty much opposed to geoengineering, but he was also pretty numerate. And I think he sadly died 6 or 7 years ago. I think if he was in this conversation now, he would be saying, you know what? We've got to be thinking about geoengineering.
Thank you, Hugh. And then, Ilona, now sort of the same question for you as well. Can text fixes solve environmental degradation and biodiversity loss? And in relation that climate change is not the only challenge. And now I'm just going to throw a little sort of like sort of last minute question that came up as well. We can move sort of a little bit more onto the policy angle. And for example, what is happening in the Arctic and what we've seen, sort of like what's happening everywhere else. Do you actually think as well that and this is an anonymous attendee that posed this question, that the real problem isn't the real problem the lack of political and financial will to make the necessary changes that are needed, but it's basically how do we engage hostile state actors when you see from where you are everything that is happening within the Arctic?
Okay, thanks. This is a very big and multifaceted question. First, I was going to say, as a comment to this techno-fix issue, that this is actually something that's been discussed in environmental policy, like environmental policy studies for a long, long time, that there are people who always wait for some technology being developed that solves everything. And while waiting for this technology to appear, actions have been postponed and postponed and postponed, because it's like, you know, it's uncomfortable if you can't, let's say, drive to working place, if you have to, let's say, walking in the rain or something like this. So I think this is just a new chapter in this old discussion that's been going on for decades. As on the willpower and the policy choices, so since Russia attacked Ukraine, So, and there's been like an energy crisis going on in Europe. So also Finland has had its share. However, Finns have been actually very motivated to save energy. We've been able to save, like households have been able to save approximately 10% as compared to the year before. And also the share of renewables has been increasing very much. So this is partly a reaction to wanting to get rid of Russian fossil energy, but also it's maybe like a point when the very long-term policies of my country are working. So, for instance, for increasing wind power, which is a really big thing in even in my country these days. Yeah. So, but if we think about climate intervention and the Arctic and the current situation where the Arctic Council it has stopped or ceased its functions for some time. So that is, of course, a problem. The Arctic Council has been suggested as a body that could represent the Arctic voice in geoengineering governance. There are some problems to that as well. It's been doing wonderful work with the scientific assessments and like that on climate change. But geoengineering would be a totally new task. But in a situation like this, when one of the Arctic 8 is not participating, or when the Arctic 8 don't work together. So this is, of course, an example of problems that may arise at some point, also in some other geographical settings.
Thank you, Ilona. And then now there are a few questions in relation as well, sort of to the role of youth educators, but we'll touch up on that area in a little bit. Now, I just want to ask Hugh specifically, how much time do we really have left? Is action in 10 years a bit too late or not?
How do I answer that? I mean, the reason I think we haven't got a lot of time left is, I guess, because of the history of how things have been changing so fast. These are global temperature rises when it's not all that long ago. I grew up in the 70s, 80s, when I in Australia, by the way, which is a hot place, where I thought it was already pretty hot. But we've seen with all the the bushfires and so on, it's worse. But I just want to emphasize that it's not just worse, getting worse globally. This is the global picture from about 100 years ago. If we wind the clock forward to now, this is maybe about 5 years ago, everything is warmer, but the Arctic is much warmer. Now, why is the Arctic important, and why is this related to the time scale? It's because if you think of the ice in the Arctic, it's melting. And once all the ice in the sea ice, the floating ice, once the floating sea ice is gone, then I think that changes everything. If you imagine the ice in your gin and tonic, or in your soft drink, or whatever it might be, if the ice in your drink had got down to that sort of level, you'd start thinking, oh gosh, I need more ice. I need a top up. If we don't deal with this problem in the next 10 years, I think it's going to become an order of magnitude more difficult. Just like it's already an order of magnitude more difficult than it was had we dealt with it 10 years ago, or 20 years ago, or 30 years ago. But let's not lose hope. The most certain thing you can say is that it's never too late. Never too late. It becomes increasingly more difficult, but it's never too late. I would encourage anybody listening to say, right, let's do it. Let's get on with it. Now is as good a time as any to get on with it. So if we wait 10 years, it'll be more difficult, but it won't be impossible.
Thank you, Hugh, and just keep encouraging our audience to keep asking these brilliant questions. Now, in relation to what Hugh said, Shaun, are there realistic pathways of emission reductions and greenhouse gas removal from the atmosphere enough to safeguard humanity? And this is sort of a very sort of deep questions. What are your thoughts?
So the real shame is that the latest IPCC report AR6 shows that the most ambitious, the most aggressive emissions reduction scenario doesn't keep us below 1.5 degrees centigrade. They actually sort of conveniently say, oh yeah, it keeps us below 1.5 degrees centigrade by the end of the century. And we'll just keep quiet by the fact that actually what actually happens between now and the end of the century, there is an overshoot. We go north of 1.5 degrees centigrade, and then we see a reduction in temperature in the latter years of this century. This is what the climate models are showing for that most ambitious, aggressive emissions reduction scenario. And the real problem we've got is that believing that we could see a pathway that will have that seriously rapid emissions reduction activity set driven by humankind at large, and then believing that actually we're even going to see reductions in temperature in the latter part of the century. I'm finding this more and more challenging to believe as a realistic, plausible pathway. It's theoretic, as I said at the very beginning. That's what the theory says. But ultimately, it comes down to, are we as a global population going to be doing this? 8 billion people collectively, this is what we're going to be doing. And it's really, really challenging. And that's emissions reduction. If you then go and overlay that with scaled up carbon dioxide emissions, carbon dioxide removal from the atmosphere, this is really important too. If I'm looking now at the years beyond 2100, which I think we should be looking at as well, in order to have a greenhouse gas level for future generations, our children's children's children, or whatever that is, so that is habitable for not just humanity, but the natural world at large, hence the earlier question on biodiversity. I think, it's going to be very difficult to sort of sell me personally that we can change this tanker into a direction sufficiently quickly to be able to keep temperatures certainly below 1.5 degrees centigrade, and the Paris agreement in 2015, which was, look, we should be looking at trying to keep, committing to temperatures being below 2 degrees centigrade and doing everything we can below 1.5 degrees centigrade. I find it very difficult to believe that just using emissions reduction and greenhouse gas removal are going to get us there, Antoinette. I wish it was not true. I really do, because this whole idea of another techno fix of marine cloud brightening or stratospheric aerosol injection, do I like those ideas? I really don't like those ideas. But actually, what I like even least is a world where we have temperatures skyrocketing, biodiversity loss. So it's a case of which are the lesser of two evils should we be considering? I don't think anyone is a proponent of geoengineering on its own at the moment at all. And I'm certainly not a proponent of geoengineering in any form whatsoever, because we don't know enough about some of the delivery mechanisms, some of the science behind this. I'm a huge proponent of research in this area. And actually what we really need to do is to arm society with more knowledge about this particular area, so that if people, if it looks that we're going to need some of this stuff, not, oh, that looks good. Actually, I also care about identifying which of these ideas are completely bonkers. And we should be telling people which levers not to pull in this area, just as much as, well, okay, some of these other levers might be less dangerous. But we just need more information, more research done at pace, so that we as a society have a lot more information to be able to make informed decisions. And ultimately it's going to be politicians globally, I think, that are going to be needed to sort of work together on these sorts of areas. But we can talk about governance and things like that in due course, and actually others around the table here are possibly better equipped than I am to be able to talk about that.
Thank you, Shaun. I've loved sort of how sort of like how energetic you get about talking of the main issues. And in relation to research, and then Alice, specifically, like in relation to what Shaun was talking, so it's like, how do you assess the potential risks and unintended consequences of a stratospheric aerosol injection, such as changes in precipitation patterns or impacts on human health? I mean, that's sort of like usually in people's mind, well, you're going to be all this stuff geoengineering. So how do you assess those potential risks?
Yeah, it's a really good question. So just to kind of give you a background on how these modeling scenarios are set up, because at the moment, we're all we're just doing the research to get the information. It's coming very much from or at least it started coming out from this sort of scientific interest background. And a lot, as I kind of mentioned before, a lot of these scenarios are, we take a high emissions scenario, we take a low emissions scenario, and we're trying to cool from one to the other. Sometimes we set a global mean target temperature and try and cool to that and maintain it. And this is set up because it's a simple method that lots of modeling communities can get together and employ in their own models, and that's great. Again, when we sort of started this research, the community decided to inject the stratospheric aerosols at the equator, and that was to really lever the atmospheric circulation patterns, which moves the air from the equator and tropics to the poles. So it's kind of like inject at one location, but still get this global coverage. But what we then noticed with all of the modeling scenarios that were coming out was that actually that doesn't necessarily give you great, it gives you more consequences than perhaps other injection strategies. So you see this really overcooling of the equator if the aerosols haven't been transported more towards the poles. And that, might sound like a great thing, but actually you then get this really negative consequence of an imbalance between the poles and the equator temperature. So that's a really negative consequence. So what we're moving towards now is trying to set up the scenarios in a way to better manage these risks. So one of the ways, for example, is to not just control for this global mean temperature target, but actually can we manage the scenarios so that we are balancing the two hemispheres and the temperature sort of difference between them, because otherwise we could move the monsoon or we have drought in certain areas. But also if we injected at multiple latitudes, which is some of the work that I'm working on, could that potentially reduce the negative impacts? And we have seen in some of the preliminary results that actually, yes, we do see a much less negative impact on the global distribution of temperature. And then again, I think to your sort of second question about the sort of precipitation patterns and health impacts, there's a lot of, I think, again, early research, we were looking very much at these sort of big climate metrics. So we were looking at how aerosol in the stratosphere impacts the stratosphere and the stratospheric dynamics, because that's really important. And we were looking at global mean temperatures, and we were looking at sort of global precipitation patterns. But I think what's also really important, because that doesn't mean much to people on the ground. If I say to you that at the end of the century, which for starters I find quite a hard concept to get my head around, at the end of the century, this particular geoengineering scenario is going to be 3 degrees warmer in this location compared to what it would have been if we hadn't have done geoengineering at the same target that we're trying to meet. That doesn't mean much to me, and I should imagine for a lot of people it's quite hard to get your head around. So some of the work that I'm doing and some of the work that a lot of other people have been doing is to look at more sort of human-based impacts and like extreme metrics. So looking at the number of days in a year, the maximum consecutive dry days, for instance. So things to look at droughts or floods. Also things like like regional patterns. So not just looking at that on a global scale, but let's look at these individual regions and maybe try and pull out some of these key extreme metrics. And I'm hopefully going to be doing a bit more work later on in the year with looking at sort of more human health impacts, because that's, again, something a bit more important for people on the ground than necessarily just the science. And obviously the sort of the climate science is great and it's really interesting. And like Shaun said, you know, we need the research. And I don't think there are many people in this sort of community saying we're definitely going to do it, because we don't know enough. And so it's really important to look at not just the global scale averages, but looking at changes regionally and even at the extremes, as well as the mean changes.
Thank you, Alice. And then you mentioned sort of people on the ground, and I think something sort of like something perhaps we don't speak about or we don't hear about are sort of like youth voices in all this sort of conversation. So, Ilona, what about youth perspective?
Thanks. I was just wanted to comment on that. I think that's a part of intergenerational justice to consider youth viewpoints. During the past maybe a year or two, I've been participating in same events with a Finland-based NGO, like youth NGO called Operaatio Arktis. Their goal is to encourage discussion on climate intervention. I think they talk about climate repair, by the way, climate repair. So in these various occasions, they and some other youth, young people, they have expressed strong interest, and there's strong support towards research on climate interventions. So basically what Operaatio Arktis has been saying is that it would be violence against young people if these techniques were not studied. Maybe they can then be used at some point if needed. Yeah, I'm also a pro climate intervention research. How can we possibly make any decisions on something that we don't know enough about? And of course, like it just needs to be developed so that it would be possible to use it at some point if absolutely necessary. But there are many framings to this and many viewpoints to this aspect. But I also wanted to comment what Hugh said about the time issue. So if we think about the Arctic, so there are like many tipping points, including the Arctic sea ice that you mentioned. So basically, we don't know exactly when the tipping point will be reached or exceeded. But when that happens, it will be basically impossible to reverse the development. We won't get Greenland ice sheet back if it's gone, not within any meaningful periods of time. So basically, like possibly considering to utilize these more targeted intervention methods that are based on more conventional techniques, such as, let's say, engineering companies already do a lot of work in the sea bottom that would be sufficient for building a curtain to the sea bottom for limiting the access of warm seawater to the glaciers. So maybe these should be used in order to avoid losing the cryospheric elements.
Thank you, Ilona. Now, Hugh, did you want to comment on the last point, or you wanted to go to the next question? So you're sort of eager to reply there, but I wasn't really sure. Okay, all right. So actually, the next question comes from Julian McQueen, and Shaun, and Hugh, I'll go to you first, since I haven't sort of got to you in a little bit. So, what about the commercial world? Does the panel think that governments should part fund emission reductions initiatives, or should it be left to the market? What are your views? And here, I'll go with you first.
Well, emissions reduction initiatives aren't going to come cheap. Shaun said right at the beginning that if we're going to replace everybody's heating systems to get off gas and oil and to go electric, well, there's not enough electricity, not enough green electricity, wind and solar and so on, being generated. So we're going to have to expand our electricity grid. We're going to have to, the amount of the cables that feed electricity into your home and into your village and into your town, and they haven't got enough capacity to supply all the heating energy that we need. So leaving this to the free market won't work. Likewise, if we're all going to go to electric cars, then of course we have to get rid of all the petrol stations that we're used to seeing all around the country and replace them perhaps with electricity charging stations. And well, if we leave that to the free market, it won't happen fast enough. And also, if we look at the way that, say, tourism works, we are addicted to flying. We love flying. I don't, what we're thinking about where our next lovely big holiday is going to be. Just have a think. Where's it going to be? Is it going to be getting the train to Grimsby? No, it's going to be flying to the Bahamas or to Australia or even to Florida. So we have to intervene. We being who? Well, we have to vote for political parties that are going to take courage and intervene, because the way that taxation systems work, the way that subsidies work, it isn't in favor of turning around this tanker of our poor energy use is concerned. So yes, there's plenty of room for enterprise in private industry. I mean, look at how solar panels have got cheaper and wind turbines have got cheaper, all because of research and investment in private companies. But we have to feed in to an infrastructure which is driven by not just local politics, but global politics.
Thank you, Hugh. And then, Shaun, before I get onto you, see Ilona sort of like shaking her head. So, Ilona, would you like to comment?
Yeah, thanks. I'd like to say a few words. So yeah, I think this path dependency is a very important point. So basically, if you have certain technology, you've chosen, let's say, if you think about the urban structure. So if the structure is such that you are basically dependent on using your car in order to get anywhere, so that's something that lasts for decades or maybe centuries. But there are of course some other things that can be done. For instance, you mentioned tourism. So absolutely, like traveling to places still requires, well, taking a plane, like if you want to travel long distances. But having worked with some sustainable tourism issues, so there are also companies that have been able to save a lot of money by switching to energy efficient practices. They've changed the shower heads, they've done some other alterations that actually have been profitable for them. So there's one incentive. And also, like in Finland, we are in the Arctic, and especially here in Finnish Lapland, for instance, this morning we had -17 degrees, but it's been -37 at some points in here. So it's essential to have well-insulated houses. So basically, by having a well-insulated house, you reduce the needs for heating in the house. And this is basically, well, you are incentivized to have a well-insulated house by legislation. You have certain requirements for houses, but also it's the money issue, because otherwise you will spend a lot of money on wasting a lot of energy. So there are ways to incentivize people to do these changes. One thing is of course like this household level things, which is not enough if it's just households alone. It needs to be also companies, and of course also public decision making can support this. Yeah, I think this was what I wanted to say at this point.
Thank you. Now, Shaun, any comments? I also saw you shaking your head. So go ahead.
So, I mean, I think there is a role for private enterprise and government in the whole of the transition, certainly in terms of emissions reduction and and actually greenhouse gas removal as well. At the moment, I think the role of private enterprise in stratospheric aerosol injection, or more broadly solar radiation management, is more challenging. I don't think the field, not just technically, but the field in terms of public appetite and governance is sufficiently developed for private enterprise to play meaningful roles in that space at the moment. But the fundamental challenge that we have for emissions reduction approaches beyond, for example, some of the technologies we've got, which are available here and now, which make commercial sense, like solar and wind, but some of the other challenges that we've discussed over the course of the last hour, the timescales for benefits and transition are quite long. And when you think about private enterprise and you think about government, they all operate at the behest of whoever they're answerable to. So if it's private enterprise, if it's a public company, they deliver quarterly reports. You know, if you just go and think about the numbers of their timescales of interest, and people get measured and compensated on timescales that are rather shorter than the timescales that I think we're looking at in terms of the transition that that's going to take, and certainly the benefits are going to be experienced for actually many of the emissions reduction and certainly the greenhouse gas removal. And that's companies, governments. I know I don't want to be cynical, but when we have democratic nations, which is obviously someone in the chat's rightly pointed out that, well, you can vote in democratic nations, but what about the non-democratic nations? But democratic nations, election cycles every 4 or 5 years. And let's think about reality. Politicians will care about being voted back in. Now, you can view that positively, you can view that negatively. But in order for them to continue with their agenda and for them to make a difference, they've got to get voted back in, and therefore they've got to sell these benefits, and therefore the electorate at large. So the biggest challenge comes down to, in democratic nations, about our timescales of interest. All right, so we have to be the ones that are driving the agenda, and voting not just for the benefits in 4 years, 5 years, or tomorrow in terms of what tax cuts can I go and have so I can go and afford more things. We need to take a different frame, and it comes back down to us and what we can do. And one of the biggest decisions we can make is at the ballot box, and thinking about what kind of world we want to, I would say, what we want to leave behind when we leave this world. And I think that's what we should really be aspiring to. And the decisions that we make today, clearly we've got to enjoy ourselves, but fundamentally I think we need to be a little bit more selfless and to be thinking of future generations.
Thank you, Shaun. And Alice, what are your thoughts on the matter? Should sort of commercial, business, government?
I guess I want to preface this with I'm not going to pretend I know a huge amount about the sort of political system relating to issues of implementing, carbon tax, et cetera, But yeah, I think it's obviously we've seen progress from the sort of market side with things like electric car prices and solar panels. And things are progressively getting cheaper, so therefore hopefully becoming more attractive for customers to buy into and therefore use more of. But it's not happening at the rate that we need it to. And I think if we'd started this perhaps more quickly 10 or 20 years ago, then today we'd be in a very different position, and we could talk about, okay, yeah, we could probably leave it to the markets. I don't know how it would look if it was more of like a government invested side, but yeah, I agree with what's been said. I think it all comes down to the voter, and I think especially now we're living in a kind of era where people are very much taking on the personal decision to make changes. So we're seeing a lot of people changing their diet and making the decisions not to fly, and I think that's great, but I think it's a really hard decision to make. And I think it's also a lot of the time the decision is taken away from those who aren't in a position to afford to take that choice. So for instance, things like flying, unfortunately, we're in an era where flying to Europe is cheaper than it is to get the train. And that seems ridiculous because the train is more enjoyable. You have a view, you're not cramped on a plane for how many hours, and you're not going to be contributing as much to your carbon output. So it's difficult because we're putting those decisions on people who are living perhaps a more luxurious lifestyle and therefore may not want those decisions. And also we're living in an age where everything, it has to be done quickly. And, you know, when we're thinking about conferences, I would love to spend 3 or 4 days getting to a conference abroad via means that aren't planes, but that's not always necessarily allowed or feasible. So it's a really hard, it's hard to leave it in the market, I think. And I think it might need to be taken to a point where it's not put on, it's not necessarily a personal choice.
I think I'd like to add to that. If you think about personal choice, one of the reasons that people spend so much time in their cars is because they have to commute to work, and the housing in many countries, many cities in particular, is unaffordable. So the people who have, you know, great jobs, you know, teachers and people who work in the police and people who work in, you know, making our botanic gardens look beautiful and so on. Well, the salaries are not keeping up with the affordability of housing, so they have to live a half hour, 3/4 of an hour drive away. Maybe luckily you live in a place with good public transport, but that's not often the case. Now, where does private investment come into this? It's a lot about policy, and housing policy has a lot to say for how we've ended up consuming so much energy.
Thank you, Hugh. Ilona, would you like to comment on that, or you're all okay? All right. So basically, and now I'm just retracing back, and this is very we can see basically that the whole topic, it has so many strands. It's not just sort of like science, but it's involved like policy, law, health. But Hugh, I just wanted to ask you a question as well that has come up. That is like, are there any geoengineering projects taking place at the moment, like coming from the science point of view?
Oh, well, that's an interesting question. Alice was talking about we know that certain stratospheric aerosol things lead to rainfall changes or but these are all computer models. These are all not actual experiments. We'd like to think they are, but we haven't had an opportunity anywhere to do actual geoengineering experiments. The closest I think we get is, if I can show you my screen here. The closest I think we get is from, if you go to your favorite search engine, you can type in these 3-letter acronyms. SCU stands for Southern Cross University. MCB stands for Marine Cloud Brightening, and GBR stands for Great Barrier Reef. And if you look on videos and you search for these things, you'll find a Facebook. You have lots of videos, but there's this one here, which I recommend you watch. It's about marine cloud brightening, and if I click on that, does that come up in the window, or do I have to open a new window? And I can put the sound on there.
It's coming up. Yeah, it's coming up.
So last year out here, we conducted a proof of concept experiment where we showed that it's technically feasible to pump seawater and atomize it into trillions per second of tiny little seawater droplets, which in theory can go on to help brighten clouds and cool the reef. This year, what we're really interested in looking at is the behaviour of that plume of sea salt droplets as it drifts away from the boat. There's a few critical questions around that. How many of those droplets make it up to cloud height? And how does the atmospheric turbulence and the winds spread those droplets? And these questions will help us to design a system for the future that may be able to work over the whole reef. This fieldwork mission has several components. One of the components is to collect background atmospheric data. So we have a whole lab set up on the ship that's sampling air from up at the front of the boat, the wind, before it hits the boat, and we're looking at all of the background properties of particles that are naturally floating around in the air out here on the reef. Another part further back on the ship is the cloud brightening prototype, and it's Mark II this year, so it's producing around twice as many droplets as last year. And we're very interested in how those droplets are spreading through the atmosphere. So we have a big focus this year on using drones as sampling platforms to measure the plume, not just in a horizontal dimension, but also in a vertical dimension. So one of the great advances that we've made from last year is really our sampling platforms. So the boat that we're using for sampling downwind is now larger and much more capable, and we're actually able to launch drones and retrieve drones off of that boat.
As well as being important to the Indigenous people of Australia, we realise it's important to all Australians. We love the coast, we love our water, let's look after it together.
Cloud brightening is just one of a whole suite of ideas that we're examining in the Reef Restoration and Adaptation program. And the overarching goal of all of this research is to look into all of the possible ways we can think of that we might be able to help the reef to survive climate change.
So just really just to say that there is stuff happening, but it is still research. It's tiny scale research. I think that the idea of marine cloud brightening, somehow spraying seawater, feels just a little bit less aggressive and less unacceptable than spraying sulfate aerosol, emulating volcanic eruptions, or emulating cloud making. I don't know what you think, Alice. Are you kind of do you have a view on whether what people think, what their perceptions are of stratospheric aerosols versus clouds?
Yeah, I think there's definitely hugely different perceptions between the two, and I think partly, I don't know if that's because we often talk about stratospheric aerosol injection alongside, like you've just mentioned, volcanic eruptions. And I actually remember telling my granddad about what my research was, and I used the example of, oh, it's, you know, we're simulating a volcanic eruption, and in my head, because obviously I'm in the world, I knew I meant that we're injecting the same aerosol into the stratosphere. His immediate response was, oh my God, volcanoes are awful, you know, you can't do that. And okay, that's a very extreme example, but when we talk about, oh, we're actually making whiter, fluffier clouds above the ocean surface to cool down the coral reef, that sounds a lot nicer and in theory less harmful. But also we're talking about two very different timescales, right? So clouds do not last as long in the troposphere as aerosol in the stratosphere, and therefore you can, you know, as we saw in that video, it's not as long lasting and impactful, and also it can be very localized. So I actually listened to a podcast that those guys were talking on about their research, and it's very small scale and it's very time frame, not just short scale or small scale in terms of sort of spatial, but time wise it's a lot shorter, whereas aerosol in the stratosphere can last as long as 1 or 2 years, even depending on how much you put up there. So
but that's interesting, Alice, because some people would say that oh God, what if you get it wrong and you put stuff up there and it stays there for 1 or 2 years? That's why it's so much nicer to do fluffy clouds. Exactly.
And, you know, from that perspective, it is, you know, you can say, oh, well, the cloud will fall out in a week. Whereas if we put stuff up into the stratosphere, it may last, you know, 1 or 2 years. So I think they're very different approaches and they have their own benefits and risks.
And perceptions.
And perceptions, yeah. And that's a huge side of this whole research, is that public perception is key, and we've seen a lot of that in the media recently, perhaps more in the sort of more scientific media outlets, but it's important that, as we've sort of said, the research is very important from all aspects. Marine cloud brightening, SAI, other sort of geoengineering techniques, but we have to be careful when we're communicating that and how we communicate it, because it can be very, very difficult, and there can be so many different perceptions of that.
Sorry, just one. I have
Yeah.
noticed the thing in the Q&A about surely cloud seeding has been researched in the past by the Russians and the Chinese and the Americans. I think we've got to be careful to point out that cloud seeding is about making clouds rain so that we can water our crops or get the water out of the clouds for the Olympics or whatever it might be. But we're talking about making clouds whiter, and that's a much more fine-tuned technology that we haven't really worked out how to do it. So yes, a lot of work has been done on cloud seeding, but this is a fairly more specialized technology, which we haven't worked.
Actually, also just to jump in there, it's interesting because I think in the scientific community, we have a lot better understanding of how stratospheric aerosols interact and the aerosol radiation interactions. And so, yes, the public perception is SAI is big and scary and it lasts for a really long time, but oh, don't worry, marine cloud brightening is fluffy clouds and it's, you know, short-lived. But actually, we haven't necessarily got the same scientific understanding of the aerosol cloud interactions. So again, that's another reason why the research is so important, because we need to understand better what actually happens and therefore what the impacts would be.
Thank you, Alice and Hugh. And now in relation to, like, you know, you've mentioned a few times, Alice and Hugh, you have also mentioned like the public perception. And I wanted to ask Ilona and perhaps all of you what your thoughts are in relation to the roles of educators. Now, Sophie Weeks on the audience, she's actually asking in relation to how do you see the role of educators in regards to all this area, especially, I imagine, I don't know, Sophie, if you're a teacher or not, but you said you don't want to terrify children, so, and you want to give them hope and useful knowledge. So what will you tell Sophie? We'll start with you, Ilona.
Yeah, that's a very crucial question. On one hand, it's very important that also children know about what's happening in the world, but on the other hand, making people terrified is not very helpful either. So without any pedagogical training, I would say that it would be important to include climate change and the different solution options to, for instance, geography classes, and increase people's to increase children's science literacy, like explain things to kids. I think that's very important. I suppose that like how we frame things influences a lot how we perceive them, like Alice's example on this awful volcano shows really well. So I think it's important that different ideas are presented as different ideas that are still work in progress, and these need to be evaluated by decision makers. But knowledge is the key.
Thank you. And then Shaun, and yeah, what's your view? And yes, Sophie has replied that she's a polar educator, so that's fantastic. All right, Shaun.
So actually, the communication of what science is being pursued, I think is only one part of this. I think there's a bigger issue, which is about involvement of people, engagement. So it's not just communication, it's about actually involving people. And I don't mean just peripherally, but helping people frame even the questions that we should be looking at regarding climate change, and therefore what sorts of research should be being done. And what I've learned over the years, there's a lot to this question. It's not just about what you say, it's about what you say, when you say it, who says it critically. And sometimes it isn't let's say the older white middle class blokes from the global north that are the best people to be engaging with certain parts of society. We might be okay at engaging with certain parts of society, but certainly not all. And we need to think very carefully as to who are the right people to bring into the table to help engage let's say younger people? Is it other younger people that should be engaging with it? I mean, we should just be open-minded as to how to sort of go and have the best conversations to go and develop this. But I completely agree that, you know, the scaremongering, which some people do adopt, I'm not in favor of at all, you know, because, you know, it isn't all doomsday. It really isn't. It's a case of, right, you know, as humanity, you know, we are sort of creative, intelligent people. And even though we might think that the odds are stacked against us, that, you know, we've got big corporations and the systems at play, and we can be better than this, all right? And I just think that we need to think very carefully about our role in society. And I think it comes down to even the communications. So, you know, it's a lot in there, Antoinette, but, you know, we have a role to play, but it's, I would say we're just one part of the big jigsaw of engagement with the wider society and helping navigate our path.
Thank you, Shaun. And then Alice, serious sort of really, again, I love your notes. It's quite easy, sort of just like, yes, it seems like you have more to say. So what are your views?
Yeah, I mean, I completely agree with what's been said. I think it's so important to engage with kids early on about climate change, because, you know, it's such, especially now, the world that they're growing up in, it's such a huge issue that they will encounter throughout their life. And also, I think sometimes, you know, we think, oh, you know, we want to protect our kids and we don't want them to like learn about all that stuff. But now it's everywhere, you know, and kids have so much more access to this information. So we need to be engaging with them on that from an early age. And in Exeter, we've had workshops with local primary schools and how best to get them engaged, and actually it proved so productive. And we had different groups of undergraduate students who came up with these brilliant ways of trying to get kids involved. And you know, that's only a small part that can be done. There's the Exeter Climate Science Centre, I think, who go out and talk to kids in schools specifically about climate change. And I totally agree, you know, I think there's a time and a place for slight scaremongering, but also we do need to make sure we're not, because people have different reactions, right? Some people are like, oh my God, the world's ending, I'm going to do everything I possibly can to save it. And then you have the complete flip side of, oh my God, the world's ending, why bother? So you really do need multiple platforms of communication with not just kids, but with adults as well, because everyone has their own priority. And sometimes they're not going to listen to one sort of pathway of communication because that's not their priority. So it's so important to have all of these different methods of communication so that everyone can get on board and just understand and get involved, because, you know, it's not something that everyone is involved with now.
Can I add?
Yes, let's go.
Yeah. So I actually forgot to mention that so kids are really interested in climate change and finding solutions. And basically, I think that if you're a kid, you grow into thinking that certain kind of climate is the normal. But when you reflect with your parents and grandparents on what used to be the normal weather at a certain point of winter, for instance, so then you learn about this. So we had a great science arts workshop with school kids in Greenland about 1 year ago. And this resulted in an exhibition. So the kids produced wonderful artworks, including a video where they showed like climate change related changes in their living environment that they had observed themselves, and somebody had been interviewing their grandparents. So I think that this could be like one pedagogical thing to do. So we're actually going to bring this exhibition to Rovaniemi later on this year. So if anybody is coming to Rovaniemi, so welcome to see the exhibition then.
Thank you. And then Hugh, we haven't heard from you yet in relation to the public perception and the role of educators. And then what are your views? You're muted.
Somebody had to do that. In my day job, I lecture to undergraduate engineering students, and And just in the last year, I've just maybe 200 students have been persuaded to sign up to find out more about this subject. But the only way that you can get them to sign up to find out more is by telling them about it in the first place. So we have to start the conversations going. They're not going to be reading about it in the newspapers or getting it on Facebook or TikTok or Twitter or Instagram. We've got to talk about it. We've got to get the conversations going. And that's why it's fantastic today, just us having a conversation about all this, and other people joining in and listening is great.
Excellent. Now, we don't have much time left in relation to this session, but it is very, very interesting, isn't it? So I would say we have about 4 minutes left. So I'll give like about a minute each. And then the question that I think we usually hear as well, it has been posed as well, is like, what can I do to make a difference, or what can individuals make to do to make a difference? So we'll go in the same order sort of like that we started. So I'll start with Shaun. Shaun, what can we do to make a difference?
So there are some fantastic infographics available on the internet, and you can go and find out which are the big things in your life that contribute to your, what we call your carbon footprint. And my suggestion would be to go and have a look at these and focus on the big levers and see what you can do about those. And I'm using my language carefully, because I'm not saying, eliminate, everything. So for example, flying. Should we just everybody stop flying? I'm not actually in favor of that. And the reason being is that I think there are other benefits to currently now to a better connected world. I am fearful of the sorts of things that can go on if we all just hide away and we're then insulated, and the sorts of things that go on in the world. If you look back in history, it's not very pretty, and therefore there are benefits to global society of a better and connected world. However, we should think very carefully about how much we fly, and can we reduce? Do we need to take that holiday? Do we need to take that holiday in a far-flung place? Do we need to take every holiday in a far-flung place? Look, what can we do to reduce our activities? Red meat. Am I going to tell everyone to go vegetarian or even go vegan? That might be a bridge too far. How about just reducing our red meat consumption? And then we might get used to that and reduce it even further. Hey, it might not take us very long to go on a journey where we end up therefore not eating any red meat or even any meat. But why don't we just focus on the big levers and see what we can do about those? The second thing is, and this is a bigger issue, which is in a democratic society, to think very carefully about our vote, what we will do at the ballot box. And but should we just do that? The political system is really important. Should we become a little bit more political? Should we just leave it up to others, or should we get a little bit more involved in our communities and figure out actually how we can go and ensure that we've got people that we would like to vote for, who are going to be representing the kinds of policies? We can't just, I don't think, just leave that up to others, but clearly we're all short of time. So those are the two things that I would have. Antoinette, lifestyle, look at the internet. Number two, think about your political actions, and for a minimum vote, but should we just leave it at that?
Thank you, Shaun. Now Hugh, in 1 minute or less.
My niece in Australia said, oh, come to my wedding. And I said, look, I can't. It's a long way to fly. So you got to come to my wedding. You got to come to my wedding. And I said, look, I can't. But here's the deal. I will give you a £1,500 cash wedding present, because that's what the flight was going to cost. And she said, really? Wow, I'm so glad you're not coming to my wedding. Now, we have to think just about what we do and why we do it and the impact it's having, and have the conversation with our friends. Keep talking about it.
Excellent. Now, Alice?
Yeah, I guess just to reiterate what's already been said, I think trying to make changes in your life that you feel comfortable making, to do any sort of small steps. And I think really importantly, just to be engaged. And I think a great first step is just to learn more about the climate that we're living in, and what people generally can do, because even if you can't necessarily make big changes to your life, being knowledgeable about the changes that could be made further down the line could be huge. So yeah.
Excellent, thank you. And then Ilona?
Well, I can only agree with what's been already said. I'd like to add one thing. As researchers, we can make a difference by doing research and telling people about it. Thanks.
Excellent. Well, thank you very much, everyone, for staying with us for this very, very interesting and stimulating session. As you can see, it covers all areas, not just science. As I said, it covers policy, law, health, and I think perhaps we should have another conversation as well, just in the future to continue. So thank you very much, everyone, and have a lovely day. Thank you.
Thank you.
Bye-bye.